Number 7. For the reaction ABC plus D, which yields to AB plus CD. And an enthalpy which is negative 55 kilojoules per mole. And we have activation energy forward 215 kilojoules per mole. Assume a one-step reaction. Draw a reaction in a diagram. Calculate activation energy reversed and sketch a possible transition state if ABC is V-shaped. Okay. So before we will treat this problem, let's discuss first the energy diagram. So we have here, suppose we have a line, a plot of potential energy versus the reaction progress. So in the y-axis, we have the potential energy, and the x-axis, we have reaction coordinate. If we have this one, which is the R, the reactant, and then we have the transition state, and then we have the product. Notice that the reactant has higher energy than the product. If you see this one, it means that it is an exothermic reaction, meaning heat is released in the reaction to form a product. Because and enthalpy delta H is negative. So what do we call the energy difference of the reactant and the product? So that is our enthalpy. Enthalpy is the energy difference between a product and a reactant. Enthalpy is the energy of the product minus the energy of the reactant. Because energy of the product is lesser than the energy of the reactant, that's why we have negative. So delta H for an exothermic reaction is negative. And what do we call the total energy? Ts is the of a chemical reaction is the particular configuration along the reaction coordinate. Also, it is the state corresponding to the highest potential energy. So, this one, it is the highest potential energy. That is the Ts. Sorry. Okay. Now, what do we call the energy difference of the transition state and the reactant? That is called as the forward activation energy, FWT, while the difference of the transition state and the potential energy of the reactant is called the energy of activation reversed. Okay, so the forward activation of energy is the minimum energy in which the reactant should surpass in order to form a transition state and then a product. Okay, it's a forward reaction. But suppose uh, when The energy of activation reverse is when we have the product already and then it go back to the reactant. So that is the active energy of activation reverse because it is from product into reactant. Forward for this one because it's from reactant to the product. Or we can write delta H is equal to rev- forward energy of activation minus reversed in energy of activation. And in this case, energy of activation reverse is greater than the energy of activation forward. So that is why we have negative. The enthalpy is negative and it is exothermic reaction. So when you see that the reactant has lower energy and the product has higher energy, that is an exothermic reaction. The reaction releases energy. Now let's go to this case. Suppose the energy of activation in the forward reaction is lower. Okay, this one. Energy of the forward. Okay. And then we have the reverse. Okay, energy reverse is higher than the energy forward. So it is an endothermic reaction. It absorbs heat for the reaction to proceed and to form a product. So it is delta H. Delta H is positive. The enthalpy is positive. Okay. So that's it. It's positive because the energy of the forward reaction is higher than the energy of the reverse reaction. So if we have that one, that is positive. Our delta H would be positive. Okay, so that's it for that. Now let's go to our problem. So this time we are asked to draw a reaction energy diagram. Okay, so we have letter A here. Okay, we have plotted the energy, potential energy versus the reaction progress. Now let's have that one. Okay, because as you can see, it's negative. The enthalpy is negative, meaning, okay, meaning it is an exothermic reaction, and we can see that the product has the reactant has higher energy, has higher starting energy than the product. Okay, so let's write that one. So we have we have it here. Okay, and then okay, Let's go to transition state, and then we have the product. Okay, so let's write what's the starting material. So we have A, B, C plus D. Okay, and we have the product, which is AB plus CD. Okay, now let's label. So the energy, the difference of the energy from the transition state. Okay, transition state is, alright, let's label. So the energy from the transition state to the reactant is the forward energy of activation, but this case the forward. And we have the, if the energy, like, difference of the transition state and the product is what we call the activation energy reverse. Okay, reverse activation energy. And okay, so the difference of the energy of the reactant and the product is what we called, sorry, the enthalpy. Okay, this one, that is the delta H. Delta H. Okay, so that is our energy diagram. Now let's go to letter B. So letter B, we are asked to calculate the reverse. Okay, energy of reverse activation energy. Okay, so we know from here that delta H, or the enthalpy, is the difference of the forward energy and the reverse energy. Okay, so we have delta H, energy of the, what is it? Energy of the forward minus E reversed. Okay, so we know that it's negative 55 kilojoules per mole, and the forward is 215 kilojoules per mole minus E reverse. So E reverse, let's put that here so it's positive. Okay, and this one, this will become positive 2 per mole. So we have that one, and that is equal to 215 plus 55, 270. Okay, 270 kilojoules per mole. So the reverse energy of activation is 270 kilojoules per mole. Okay. So as we can see that we can identify that we have the correct answer because the here in the diagram we can see that the reverse energy of activation is greater than the energy of the forward reaction. And here 270 is greater than 215. So we can no see that we can say that our solution is correct. Now let's do letter C. Sketch a possible transition state if ABC is V-shaped. Okay, so we are going to draw its configuration, the structure. So we know that in the transition state here, okay, right, the TS, okay, the transition state has the highest potential energy. Okay, it is the highest potential energy. And then in a transition state, it is short lived. So it is a short lived molecule formed in between the reactant and the product. So the TS, the transition state structure, forms here in the highest potential energy. So that's why we write the TS. This is the point where we can see or we can where the molecule form. Okay. But please bear that the TS is short-lived. Okay, because it's short-lived because it's just ABC collides to B here, so they collide and then it forms a product. So that's the product. So A, B, C, and D is the TS. Okay, now we can write that one here. So we have the A and the B. Okay, since it's V-shaped. Okay, and I'll write that C. Okay, so this is the reactant. Okay, the reactant. Okay, the first molecule, and then we have because in the TS, ABC will react. Okay, so they will collide, and then so we can it can form a D. Okay, molecule D. So that's it. ABC is V-shaped, and then because in the transition state, it is the state where the molecules uh, partially collide, and then partially form a product, partially form, and then until it forms a real product, which is A, B, C, and D. So I put the dots here because it means that it is here. Here is the bond breaking. Okay, bond breaking. And then we have the bond forming here, forming. So this is letter C because in the product we have AB plus CD. So in the AB, the bond here is the bond breaking, and then the bond here is the formation of the CD to form the product AB plus CD. Okay, so this is our transition state structure. So it is a short-lived, it is short-lived course in between the reactant and the product. So here, we can see the transition state structure in the highest potential energy. Short-lived lang siya kay mo form man siya dayon og product. Okay. They meet and then they form. So here the A, B, C, and D collides, okay, and then they partially react to each other, react, and then they form a product. So here the CD, okay, the CD in the transition state collides. Okay, they collide and then they talk. Okay, and then it forms a product na dayon. So it's just short-lived because they will transcend to a new form. Okay, so that's it. This is letter A, letter B, and letter C. Okay, if your answer has no label like this band breaking and then band forming here, it's okay. As long as you show this one, it's correct. And of course, it's V shape because it says here it's V shape. Okay, so that's it.